Hi dear students, welcome to my YouTube channel Maths Insights. In today's video, I am going to explain 4 different types of matrices which are very useful. First type of matrix is Idempotent Matrix and second one is periodic matrix. Third one is Nilpotent Matrix and the last but not least, that is Involutory Matrix. These are very important. Shall we discuss? I have written all the names of the matrices which we are going to discuss in this video. The first one is Idempotent Matrix. If any square matrix, let A, if A is a square matrix and if it is idempotent matrix, when it satisfies the relation that A square is equals to A, that means A is a square matrix and if you multiply it 2 times, then if you are getting back the same matrix again, then A is said to be idempotent matrix. I will once again say the definition. A matrix, a square matrix A is said to be idempotent matrix if it satisfies the relation A square is equals to A. Whenever A square is equals to A, automatically A power n always becomes A, where n belongs to set of natural numbers and it should be greater than or equals to 2. Why? Because whenever A is idempotent, A square will become A. Suppose I am taking an example. A power 5 I am taking. A power 5 will become A when A is idempotent. Why it is? A power 5 can be written as A power 4 into A. A power 4 can be written as A square whole square into A. Since A is idempotent, A square may be replaced with A as per the condition. Therefore, in the place of A square I am writing A. This is A square into A. Again, since A is idempotent, A square may be written as A. Therefore, it will become A into A, which is A square. Again, A square gives you A since A is idempotent matrix. In this way, you may say that A power n, that means A is raised whatever the power, that gives you again A when A is idempotent. Next, second type of definition is periodic matrix. A square matrix, let A, whatever the name may be, you may take A, B, C or D, whatever it may be. A square matrix A is said to be periodic if it satisfies the relation A power k plus 1 is equals to A, where k is positive integer. Whenever if you take a matrix A and A power k plus 1 is equals to A, that means I am taking an example for this. Suppose A power 6 is equals to A. This 6 can be written as A power 5 plus 1, that is equals to A. Then A is said to be periodic. It has to satisfy the condition A power k plus 1 is equals to A. Example, whatever it may be, A power 5 plus 1, k value is 5. In this case, if k is the least positive integer, then that k is said to be the period of this matrix. Suppose I am taking another value. Even A power 9 is equals to A, which is written as A power 8 plus 1, that is equals to A. Sorry, this is A. Okay, A power 8 plus 1. In this case, A power 6 is equals to A. In this case, A power 9 is equals to A. Both may be possible. Why it is? This is a periodic, that means it reoccurs. In this case, k value is 5. In this case, k value is 8. Whatever the least. Here in this case, least value for k is 5. That 5 is called period of the matrix. When A power 6 is equals to A, it should not be A power 5 is equals to A. Why? Because when A power 5 is equals to A, period of that matrix will become 4. So, it should not be. If it is A power 5 is equals to A, then the period will become 4. Why? Because 5 can be written as 4 plus 1, A power 4 plus 1 that is equals to A. This is the period of the matrix. Next, third type of matrix is nilpotent matrix. Nil, the name itself says, nil means null. Whenever a matrix, I am taking in all these cases my example as A matrix A is said to be nilpotent matrix if A power k is equals to O. A power k is equals to O. For this I am writing A power k is equals to O, and also A power k minus 1 should not be equals to O. Then A is said to be nilpotent matrix. I am again saying A is a square matrix and it satisfies the relation A power k is equals to O. That means if you multiply A 5 times, if you are getting a null matrix. Null matrix means which contains zeros, all elements as zeros. Then this matrix A is said to be nilpotent matrix. Similarly, whenever A power 5 is equals to O, it should not be A power 4 is equals to O. It should not be equal. Then only this K is said to be the order of the nilpotent matrix. The last one is involutory matrix. A square matrix, let A, is said to be involutory matrix. Then if it satisfies the condition A square is equals to I, where I is the identity matrix, A is the any square matrix. If you do multiplication 2 times the same, if you are getting the same identity matrix, then that A is said to be involutory matrix. In this case, A square means it can be written as A into A. Whenever a matrix is multiplied with another matrix, if the result is I, then the second matrix is said to be inverse of the first matrix. So inverse of A is A inverse. You can write inverse of A as A inverse. If that is equals to A, then this A is said to be involutory matrix. So these are the 4 types of matrices. In all these cases, whatever the matrix you are taking, that must to be a square matrix. So first one is A square is equals to A, then idempotent. A power k plus 1 is equals to A, then A is called periodic matrix, where if k is the least one, then k is said to be the period of the matrix A. Third one is nilpotent matrix. The name itself says that null. Nil means null. If A power is equals to O, then k is said to be order of the matrix. And also the important one is A power k minus 1 should not be equals to O. Third one, last one is, fourth one is involutory matrix. If A square is equals to I, then A is said to be involutory matrix. These are 4 types. We can better understand these types of matrices by taking some examples. Shall we? I have taken 4 matrices which you have to show that idempotent, periodic, nilpotent, involutory. 4 problems. In all these 4 examples, I have taken 2 by 2 square matrix for easy understanding. You may take 3 by 3 also. If you see the first A is, they have given 2 by 2 matrix, you have to show that idempotent matrix. That means you have to show that A square is equals to A. When you multiply these 2 times, you have to get again A. 4 minus 1, 12 minus 3, and 4 minus 1, 12 minus 3. This is matrix multiplication. I made a separate video on how to multiply 2 matrices, but I am doing this now without more explanation. You have to multiply the elements of first row with first column. So 4 4s are 16, right? And you have to move it to the second element, here also second. 12 ones are 12, but minus is there, therefore minus 12. First row, second column, 4 into minus 1, this is minus 4. Okay, and minus 1 into minus 3, which will become plus 3. Similarly, second row, first column, 12 4s are 48, minus 3 into 12. You have to move to the second element. Here also in the column second element. 12 3 is a 36, but minus 36. If you see second row, second column, 12 into minus 1, minus 12, plus minus 3 into minus 3, plus 9. Okay, that is equals 16 minus 12 will give you 4. This is minus 1. 48 minus 36, 12. Okay, and this is minus 3, which is equals to A. So A square is equals to A, then A is an idempotent matrix. Coming to the second problem, show that A is a periodic matrix. Periodic matrix means if you multiply a matrix, whatever the number of times, you have to get it again A. It may you may get A in the fifth multiplication or fourth multiplication, whatever it may be. But in this case, if you multiply, what is the A? 0, 1, minus 1, 0. You have to multiply this, the number of times until you get A. That number of times you have to identify which is. So I am doing A square first. Okay, A square means I am writing 0, 1, 1, minus 1, 0. You know how to multiply two matrices. First row, first column, 0 into 0, plus 1 into minus 1, minus 1. Next, 0 into 1, 0, 1 into 0, 0. So total 0. This is minus 1 into 0, 0, 0 into minus 1, 0. Okay, minus 1 into 1, minus 1, plus 0 into 0, 0. So minus 1. This is what? A square. If you multiply A square again with A, what the result? Minus 1, 0, 0, minus 1. I am multiplying by taking A again, 0, 1, minus 1, 0. You have to multiply it in the similar manner. First row, first column, minus 1 into 0, 0, 0 into minus 1, 0. Have you got A again? Not in this case. You have to get back A until you have to multiply with A again and again. So I didn't get it, that's why I am multiplying the result of A square with A, which will give you A cube. So 0, minus 1 into 1, minus 1, plus 0 into 0, 0. So therefore minus 1. Next, second row, first column, 0 into 0 is 0, minus 1 into minus 1, plus 1. Therefore 0 plus 1 is 1. Second row, second column, 0 into 1, 0, plus minus 1 into 0, 0. Have you got A? What is A? In this case 0, 1. No, you didn't get. So you have to do again. This is A cube. A square into A is A cube. Again I am doing A cube into A. That is equals to, what is A cube? 0, minus 1, 1, 0 into A. What is A here? 0, 1, minus 1, 0. I am multiplying. 0 into 0, 0, minus 1 into minus 1 will give you plus 1. I am writing here plus 1. First row, second column, 0 into 1, 0, plus minus 1 into 0, 0. Okay. Next, second row, first column, 1 into 0, 0, 0 into minus 1, both are zeros. Therefore, your answer is 0. Second row, second column, 1 into 1, 1, plus 0 into 0, 0. 1 plus 0, 1. Have you got this here? No, even now you didn't get. Therefore I am doing A power 4 into A. This is equals to A power 4. I have to multiply A with whatever the result until you get A again. A power 4 is 1, 0, 0, 1. If you multiply it with again with A, what is A? 0, 1, minus 1, 0. Come on, result. 1 into 0, 0, plus 0 into minus 1, 0. 0 plus 0 is 0. First row, second column, 1 into 1 is 1, 0 into 0 is 0, 1 plus 0 is 1. Okay. Next, second row first column, 0 into 0 is 0, plus 1 into minus 1 minus 1. Last, second row second column, 0 into 1 is 0, 1 into 0 is 0, 0 plus 0 0. Check whether you get it or not. 0 1 minus 1 0, therefore that is equals to a. That means after multiplying a 5 times you are getting back a. This is periodic matrix. The question is, what is the order? When you write these 5 as 4 plus 1, that is equals to k, you have to write in the form of a power k plus 1, my dear students. Therefore order of the period of the matrix is 4. If you take the fourth one, you have to show that the given matrix is a nilpotent matrix. In this case, first one is idempotent, means a square is equals to a. Second one is a power k plus 1 is equals to a. Third one is nilpotent, means a power k is equals to o, and a power k minus 1 should not be equals to o. So in this case also you have to multiply a with a, you will get a square. If you get o, that's. If you don't get o, you have to go further by multiplying with a again, my dear students. This problem is third one. What it is asking, show that a is equals to is a nilpotent matrix. We know that a power k is equals to o, and a power k minus 1 should not be equals to o. You have to do the product of a, first a into a. If you get o, then that's over. Otherwise, if you don't get, you have to go forward again multiplying a square with a. Now I am doing a into a, that means a square. A square is equals to 2 minus 1 4 minus 2, and this is again 2 minus 1 4 minus 2. You know very well about how to multiply two matrices. First row first column, 2 to the 4 plus minus 1 into 4, therefore 4 minus 4. This is the first element. First row second column, 2 into minus 1 minus 2, and plus minus 1 into minus 2 plus 2, therefore 2, this is minus 2 plus 2. Next, second row first column, 4 into 2 8, plus minus 2 into 4 minus 8, therefore 8 minus 8 in this. Next, second row second column, 4 into minus 1 is minus 4, plus minus 2 into minus 2 is plus 4, therefore minus 4 plus 4. Then if you see the elements, every element will become 0. Okay, 4 minus 4 is 0, plus 2 minus 2 cancels and gets 0. This is 0 and this is also 0. Therefore this is nothing but o. Therefore in this case what you are getting, a square is equals to o, means this is a nilpotent matrix. The question arises, what is the order of this nilpotent matrix? It's very clear that after multiplying 2 times you are getting o, therefore order is equals to 2. So order of the matrix, nilpotent matrix A is 2. Coming to the fourth one, what it is asking, show that A is equals to is a involuntary matrix. If a square is equals to I, then that is said to be involuntary. Now we have to multiply a 2 times. First one is a square, I am writing a square is equals to 2 3 minus 1 minus 2. Again we have to write 2 3 minus 1 minus 2. Multiplication again. 2 into 2 is 4, plus 3 into minus 1 minus 3. 4 minus 3. Again first row second column, 2 3 is 6, plus 3 into minus 2. So 6 minus 6. 6 minus 6. Second row first column again, minus 1 into 2 minus 2, plus minus 2 into minus 1 is plus 2. Therefore minus 2 plus 2. Second row second column, minus 1 into 3 is minus 3, plus minus 2 into minus 2 plus 4. Therefore minus 3 plus 4. that is equals to 4 minus 3 is 1, 6 minus 6 is 0, minus 2 plus 2 0, this is also 1. So you are getting I. Therefore A is said to be involutory matrix. Why? Because A square is becoming I. So these are the 4 important definitions in matrices. I hope this video is very helpful to you. If you like this video, don't forget to share it and like it, which gives me encouragement to do more videos in this series. Thank you very much. We will meet again. Until then, have a nice day.